Thank you everyone for joining and spending some time with us today at Avesha. Before we get started with today's demo, I want to give you a little bit about Avesha ourselves. So our mission is to create a revolutionary set of applications that offer single cluster, multi-cluster, multi-region, multi-cloud, on-premise and edge Kubernetes cluster management, connectivity, and intelligent workload placement. So before we dive into what we're going to do today, I just want to do little intros myself. My name is Rob Courteau. You can reach me at rob@avesha.io. I'm the Director of Enablement here at Avesha, and my background is primarily in Unix, digital transformation, and cloud migrations. And with me here today, I have Prasad, who is the CPO of Avesha. And if you want to take a minute or two, Prasad, to talk about yourself.
Thanks, Rob. My name is Prasad. Welcome to the team. Come in. We are excited to show you what we have built, and it'll be useful for people doing this digital transformation. My background has been in networking. I've been doing a lot of transformations for different companies, and as well as building products. I'm the co-founder for Avesha Systems and leading the product roadmap. Go for it, Rob.
All right, great. So what we're going to show you today, what you're here to see. So we're going to demo our KubeSlice product, and that's going to consist of connecting multiple clusters in AWS. And then we're going to connect a third cluster that we've created in GCP. Then we're going to create what we call an application slice across all three clusters with a distributed workload. And then we're going to demonstrate that connectivity using the iPerf application between all three clusters. And along the way, we'll describe what the software does, the benefits, the features, and we're going to dive into the demo. So before we actually get into the meat of the demo, feel free to ask any questions you might have. We'll be moderating the channel, so we'll answer those questions for you. And if you like today's content, please feel free to like and subscribe to the channel. We'll be doing more of these live events every couple of weeks. So with that, I'm going to turn it over to Prasad, and we're going to get right into the demo. Prasad?
All right, thank you. I will start sharing from now on. So you would see a lot of things in the demo, right? I hope you guys can see my yellow screen, which has, it's a Unix window. Let me just get started by saying today I have a bunch of aliases. I'll be using a whole bunch of commands. The kubectl command is what is abbreviated to kubek, and as well as different tool sets which has been installed to make it simplify to show you the power of how we can be in the clusters, and then be helpful with the tool sets, which whatever you already have, you don't have to do anything new tool sets, right? So and without further ado, you can see, as Rob mentioned, we have three clusters. A cluster in EKS, and a cluster in another EKS, and as well as a cluster in GKE. You can literally do it for your on-prem clusters or any cluster you have, or different clusters in different clouds. Today, our mission, as Rob mentioned, our mission is to show you how simply you can have clusters in different clouds. And assuming that you already have workloads running in, and then you're trying to add more workloads, we will show you how how to connect them, right? So that's the thing, right? As you can see here, we have two clusters.
Before you begin, Prasad, can you just increase the shell size so the font's a little bit easier to read for?
How about that?
Can it go a little bit bigger if you don't mind?
I think because of the situation with Google Meet, it cannot go anything beyond this, unfortunately.
Okay.
Is it too small for people to see? Right.
I'm asking. I think we're good now.
All right. So as I mentioned, right now I'm going to work on showing you there is an EKS cluster, and Rob, I will not be monitoring the Google chat. If you want to monitor and then prompt me on the Google chat, please let me know.
Yep.
Right? Uh,
So if you want, what we can go through right now is
register
show.
clusters.
Yep. Well, first we'll start with the labeling of the nodes on the clusters for each one.
So I have a small, script which tells you that you're going to show you the labels. So as Rob mentioned, we define a label per node as gateway. That is the place where that's the opportunity where gateways can be put up to talk across clusters. So that's the label, which is Avesha slash node type equal to gateway. So if you go to any cluster, typically we would want to have redundancy. And the redundancy reason why we label it to two nodes, so that if one node has a failure, it actually flips into the second node for the availability. That can be in different inside the same AZ, but different zones, right? So that way you have the redundancy aspect of it. As you can see, I have a zone US East 1 B, and then East 1 A and B are the places where we have, right? Now let me show you in order to register our cluster, we have a YAML file which you put it in. This is the key to have a centralized cluster management software, which actually is a broker cluster, brokering all the worker clusters. So this is as simple as we install it as a simple command, right, through a Helm chart. You can go say that I want to install in ES East 1A like this, right? That is actually registering with the broker cluster on the back. And KCTX is the context. I'm going to change the context to the second cluster. And then once I change the context, I install it to the second cluster there for the Helm charts, or installed it there, right? Then I will switch over to GCP and then install the GCP.
And so while you're doing that, Prasad, the flow of the installation of the application is what we're going to do is we're going to register all the clusters. So if you had 3 or 4 or 10, it doesn't really matter. What you need to end up doing is create the YAML file for each cluster that you want to have your applications be spread across.
Yep.
So what we're doing now is just identifying, and in the YAML file, you'll see there that we give this the region that it needs to be in, the node IP of the gateway node, which allows, once the operator is installed, that selects that particular node to install the gateway components, which will do the ingress and egress across those clusters to the gateway nodes and the other clusters that you've registered, creating an underlying mesh of connectivity between all the clusters.
Thanks, Rob.
You're welcome.
So thus far, what we have done is we have created registered 3 clusters into our broker cluster, right? So next step, if you look at KNS, KNS Avesha system is the namespace where we instantiate all our pods. The pods are all coming up. So if you can see, this is the manager, which actually manages the cluster, which is talking to the broker cluster. And then we create an overlay network. In order for an overlay network across the clusters, we will tell you the benefits of overlay network as we go along. And then you can see that all the pods are up. We also have a DNS component, which actually holds all the import exports of all the workloads which are going to be across cluster communications, right? If you want to have service-to-service communication, which is a disaggregated stack, you can export the services, and the services are available to any cluster which is part of the slice. We'll talk about the slice in a minute, right? I will go back to clusters, and then I will start installing a concept called a slice, right? Let me show you what it is. I am inside the cluster, AWS now, right? And then I'm going to go to slices YAML. I will show you, I'm going to create two segmented application slices. What is an application slice? It is a slice of an overlay network for all the associated all the associated workloads combined together across multiple clusters. So if you look at it, I'm going to create something called an engineering slice and as well as security slice. Engineering slice, it says that it is for product engineering. So they are distributed on two clusters. And then let's say a security slice is distributed on all three different clusters. You may have the prioritization on the cluster, and as well as certain namespaces which can be associated to that slice. While the installation of a slice is the simplest way of using an YAML, right? Like the way I am showing it to you here. You just say install the slice. Right now I am on cluster EKS cluster. I am going to install the slice on EKS, and I am going to go to EKS cluster 2, right? This is inter-cluster connectivity. So I go to EKS cluster 2 and do the same thing, right? Engineering slice. And now you have, once the gateways are connected, you will see that, a slice is created for highway path between the two clusters, right? Let me do one other thing. I will do go back to go back to EKS1, and then I will start to install the other slice, like what do you call security slice. And now, let's say in this case, you want to have security wants to have presence in every cluster, right? So it goes here. You establish a slice in EKS1, and you can establish the slice in EKS2 for security cluster, right? Now I am going to create, I am assuming that this also needs to be there in GKE. I am going to, switch over to GKE, right? And then create the cluster there, right? It's as simple as Helm chart. It's the same thing, installing it, right? So essentially what we have done is created an overlay network across all three clusters, right? So if I go back to, uh, you know, EKS1 and then say kget slice. So by the way, before we do that, we are an operator, right? Inside a Kubernetes cluster. If you see kget CRDs, we have custom resources defined, right? These are, we have a Calico, or even Istio can also be coexist with it. We don't really need Istio, but you can also coexist with it. We are native inside our Kubernetes. So if you look at it, we have service export, service import, mesh CRD, and gateway CRD, and an ingress CRD. So you can create these CRDs by installing the mesh. We have created the CRDs, right? So if you look at it, where KNS, I am in Avesha systems, kget slice sys. So it tells me on this cluster there are two slices, kctx minus. Now I am in GCP kget slice. I only have one slice on a GKE, but if I go back to context to EKS, right, I get two slices, right? By the way, if you can observe that each of the slice has the same subnet as uh, other slice. So literally, you can use the same overlay network from an addressing standpoint to communicate from a service to service. You don't have to do an IP address planning. Your clusters will literally become a template. So we don't have any cluster with an IP address space. Whatever you have, we can consume it. As long as this overlay address is unique across the clusters, you can literally templatize the cluster creation, 10 dot address space in all over the place, and don't have to address any of the network components. We automatically take care of it, right? So kget slice gateway minus w.
So while you're doing that, Prasad, I just want to add a little bit of color just in case there's some confusion. For the audience, if you think of a slice like a VPC for your application, it's completely isolated across all of the clusters in the environment. The regular traffic that happens inside your existing Kubernetes clusters, so if you have local workloads running in one cluster, it doesn't traverse over the NSM network. It stays local, and it uses the local CNI attached to that cluster. So any inter-cluster communication goes over the CNI. It's only when it needs to talk to one of the multi-clusters that it's connected to that we route that traffic over the NSM network that you see here on the screen, which is the 192.168 across for that communication, for that east-west traffic that gets encrypted across the clusters. The other caveat that we're trying to show here is the IP management, even though we glossed over it quickly, is a huge win. If you had to do any other IP management, say with Anthos, or trying to do this natively on any other cloud provider, you have to do a lot of IP management, frankly. So with our product, as long as the NSM network is in the RFC 1918 space, it could be 192, 172, 10 dot, as long as it's not conflicting with your underlying CNI address space, you're good to go. And you can reuse that address space across every slice on the cluster, like Prasad said, and we're going to go into a little bit more detail here on what that really means.
Yeah, as you can see here, right now, while I am talking to you after executing the commands, right now I have created paths from in here. You can see I have created a path from one EKS cluster to another EKS cluster. Remote cluster is already there. The same cluster is connected to a GKE cluster, and as well as the same cluster is connected to another EKE cluster. So literally you created a mesh across all three clusters. And this mesh is also segmented because security is the only slice which is out there across all three clusters. But engineering slice is only there in two clusters. So you have the flexibility of picking and choosing how many clusters you want to connect and what division. When I say security and are not, right, K describe or get slice, I kind of wanted to think like, let's say you have a product team, and then the product team wants to have connectivity or is in a single cluster today, and they want to extend it to multi-cluster scenario. You can shard the network of product team across multi-cluster and only give limited set of resources for that product team, so that you don't have to create a full network or full slice or full cluster. You can use the existing clusters for some other purposes, but you create that isolation and as well as create a highway from across multi-cluster. So geographically, it can be distributed. It can be distributed on multi-cloud scenario. All of that are possible. Right now, security being security, they need to be in every cluster. So they would they would look at this and say, okay, I need to have a presence in every cluster which you have. Now you can carve out a security team's network and then put all the security team workloads, like for instance, it's a SIM or some kind of a analysis tools which are out there, which is monitoring all the other namespaces inside the cluster. They can all be segmented and put it in, and then you have different sets of policies. While I talk about security and as well as isolation, this is one thing which you have to realize, right? Let's say I have namespace called team engineering. Can right? Team engineering is only interested in team engineering's workloads. You don't want to have contamination of team engineering workloads to somebody else. So we automatically create a name, a network policy on the team engineering namespace. So if you describe the network policy, right, you can see that you are allowing all the workloads which are on the slice called team engineering, and then you're allowing some housekeeping things like cube system, because you need to have the scheduler looking into it and all that stuff. And then you also need to have Avesha system, where the components which need to talk across the clusters and all that stuff, that needs to be there. So the rest of it is protected such a way that no other traffic happens. So if you have 3 or 4 namespaces, you can define that cluster for namespaces inside, so if you look at it from an isolation, isolation enabled is a simple YAML file when you create a slice. And then you can define the application namespaces here, however many number of application namespaces you have, and then put a wildcard to say, I don't want to keep changing the parameters. I can keep on however many number of clusters I would have, please apply it to that. Or you can specifically say which cluster you want to apply, or you can have it as a broader open perspective. So this gives you the isolation and control from an InfoSec standpoint. There is no cross-contamination. There is no chatter, which is going to impact any other person. So that's the key value from automating a lot of these things in the Kubernetes infrastructure. Okay.
And before we move on, Prasad, I just want to draw their attention to the line. If you could highlight the QoS profile, high priority profile.
Yeah.
Part of the application stack is we also have a QoS profile. So any application that you have running on a slice, we're also able to do traffic management for that particular application. if you have a critical workload that's running on your cluster and it needs more bandwidth than, say, another application on that cluster, we're able to give priority via how many megabits per second you need that particular slice to have throughput for, and throttle the other slices in a min-max type value at your discretion, whichever you need for. So right now, out of the can, we have this high priority profile that's set up to 5 megs. There's a medium and then a low, which has those thresholds, but those are configurable, and you're able to create your own based on your own application needs. So you can create those yourself.
Yeah, every slice has, thanks Rob for pointing it out, every slice has priority. And the slice is inter-cluster communication, and then we also enable the traffic shaping, traffic control inside the pod or the nodes. So now you have a fast path to having the pod network functionality is better managed through prioritization. Right? And then at the edge of the clusters, we have a leaky bucket. We manage how the things need to go. So they're a much better way of controlling the traffic which is going across clusters. Now, while we talked about the infrastructure, let's talk about how do we put sample applications, right? KCTX, currently I want to go into cluster 1, which is essentially, EKS cluster, right? Let's say I'm going to install iperf server onto a slice. So what does iperf server installation onto a slice mean, right? So let's say KNS, I am in team engineering. Team engineering has an app, and then they are going to install iperf server inside the EKS one, right? Server engineering EKS one, or this thing. All they need to do for their application, this is their application manifest by itself, right? All they need to do is annotation here for which slice this particular application is going to be, right? So obviously the namespace is their namespace for the application, but the annotation which we added is that by saying that this is the namespace which need to be there. And then if this iperf server needs to be shared or exported to other clusters, somebody else wants to talk to this, you just put an export manifest for iperf, and then we show you how it is accessible to other clusters. So I do same as k apply, -f iperf server engineering YAML -n, just to be safe, team engineering, right? That is where I am going to apply it, right? So now, so not only that the application is deployed, now it's also created an export. So let's assume that I am going to go to EKS2, right? And then I'll say now here I want to put a client in team engineering, right? KNS team engineering. Sorry, I have to miss team engineering, and then I am going to install iperf client in this different cluster, right? So there is nothing much here because you don't have to do anything, because all you need to do is that this particular thing needs to be in on the slice, and then nothing in the YAML or nothing in the manifest actually changes, because you're not exporting the service. The service is not reaching to anybody else, right? K apply -f iperf sleep, and then engineering.
So while that's applying, the long and short of the message here is your existing workloads, you don't have to change your manifest to work with our software at all, except for that one annotation line. That's all it takes. You create the slice and that application workload for that slice. You change the manifest file just to add the annotation, and then it's onboarded onto that slice and all the benefits of the tenancy, the QoS profiling, etc. And if you were going from a single cluster to multi-cluster, you could re-architect your microservices however you want on that slice to run across the different clusters. So that's how you would gain that multi-cluster effect, just by just running those bits of the microservices application in the regions that you want to, that would make sense for the application. Whether it's for latency purposes, you want to get closer to the users with some of those different services, or duplicate or redundant across clouds, just to make sure you're covered from an HA and BCP kind of standpoint.
Yeah. So thank you, Rob. So let's assume the kget pods here, right? I am inside the KNS. I'm inside the namespace of team engineering. I have only one pod, but kget service import, right? Because somebody must have imported. Did anybody import any service? There we go. You got an import from other cluster. So literally, if the other cluster, so if I go to kctx minus, which is essentially the cluster one, KNS team engineering. Sorry, thank you. K get service export. This guy has exported 2 instances of endpoints into the other cluster. So literally, all you have to do is put that YAML file. The operator would propagate that in the mesh, and then you have a better way of communicating across clusters. So now I am in cluster 2, right? I got kget pods, right? Now I'm going to say k exec minus it the pod, right? And then minus c iperf is the client, the container which I want to log in, minus sh. So I am inside the container. So you know that I don't have any iperf server inside this container, inside this namespace, or in the cluster, right? There is no iperf running inside this cluster, right? I will let me just show you, right? As in k get pods minus a, right? This is telling me all the pods which are inside this cluster, right? You cannot find iperf server anywhere in this pod, right? Pipe it to grep iperf server, right? It's not there, right? It is not there. So, but when I go into this pod, right, iperf minus c iperf server, right, and the namespace which is in team engineering dot service dot slice dot local, because that is where that pod is on the slice, and then 5201 is the port which it exposed, and then my every interval of 1 second, please send some data, right? Minus b 10 meg, right? So you can see that here the iperf server, the local interface is at 192.168.2.5, and it is connected to 192.168.1.9, which is essentially the part which is sitting inside across the clusters, right? This way, you are literally having to have a dual homed interface to a pod. So ifconfig, if I show you that this is your CNI interface, right? This is your CNI interface which is sitting in the cluster, right? And then this is your intercluster interface, wherein your intercluster interface is where you communicate to across clusters, right? This is simplest way of having to have across clusters connectivity, and then have workload distribution much easier, right? So let me get out of this thing, and let me show you something which we can do across clouds now, right? So so I'm going to focus on namespace, or the cluster, or the slice, which is team security. Thus far we talked about team engineering, right? So let me go to GKE, right? KCTX, and I'm going to go to GKE. I am in GKE right now, right? And then I'm going to go to GKE. I have scripts written such a way that it is I am going to have a server in GKE, iPerf server in GKE, and bunch of clients in two different clusters, right? EKS1 and EKS2. So let me install, right? KNS team sec, right? I am inside the team security, right? And then I'm going to say k apply -f iperf server of security, right? And then -n team sec, right? So now this is what we deployed it, and then we are exporting this to across all the clusters which are part of that slice. This slice, as you can see, describe slice sec team, right? If you go k describe sec team -n Avesha system, you can see that this particular slice is not only attached to the GKE cluster, it is attached to EKS cluster, and it is attached to another EKS cluster. So literally, this slice, I exported this service by one YAML file, right? More iperf server YAML file, which I said, please export this service on this slice. So literally what happened is that get service export here on this, it is exported, right? Now KCTX minus, right? Now I'm in EKS cluster, KNS team sec, right? I am inside the team sec. There are no pods yet. There are no pods yet because I have not deployed it yet, right? But kget si, si is another way of service import. Inside this, it says, oh, I have an availability of an iPerf server, which is not there inside here. Now, when I go to KCTX, and then I'm going to go into this cluster, Control C, KCTX onto that, KNS team sec, right? And then if I do get pods, there is nothing here but get si import, right? You can see that this is already there. So you have one workload which is sitting in GKE, is exported to multiple clouds or multiple clusters. In this case, two different clouds, two different clusters in AWS, right? So now let me put an application inside this, right? Sample application in here. So k apply iperf sleep, and I am in a security namespace, ThemeSec. So, oh, sorry, minus F. I forgot the minus F. All right. So I am in, I am in cluster one, and then I applied it to, you know, I launched an application which is local to EKS cluster. So now I can get pods, right? So the pods are running. Let me do get k exec minus it, right? This pod minus c iperf minus minus sh. I get into the shell. Now realize I want to talk to all the workloads which are on that slice, right? So I'm going to say iperf uh, minus c iperf server dot team sec, right, dot svc dot slice dot local. Now minus p 5201 minus I 1 minus b 10 megabits, right? So here, what's happening is actually from EKS, you're able to communicate to GKE. So look, we have done this demonstration from a clean slate of nothing there. So you have connectivity done in less than 10 minutes. You have deployed an application, and you are able to have the application communicate to that. You have created a namespace isolation, and then you have created policies, and then you have created mesh DNS. One thing which I needed to show is kget ksdescribe config map mesh DNS, sorry, minus n Avesha system, sorry. So, oh, sorry, I didn't get out of the I didn't get out of the shell, right? So ksdescribe config map mesh DNS minus n.
It's DNS. You have DNA again.
Oh, DNS minus n. Thanks, Rob.
You're welcome. Big brother's watching.
All right, so you can see it here. We have sharded even the mesh DNS traffic, right? So literally what you are doing is inter-cluster routing is done through a local DNS, which we bring in, so you don't have to pollute that thing in your kube DNS. So this way you can isolate per slice basis what is advertised and what is not advertised, so that you don't have to worry about others touching it. And also the fact that you know you are controlling your control plane traffic, right? This is something which is very useful from a cluster management standpoint, right? So let me just show you some internal details. Rob, should I talk about the router?
Sure.
I know we have 15 minutes. So, right, get pods. So literally from a pod standpoint, as I told you, there are so-called dual interfaces, which is actually going to multi-cluster scenario. So if at all, I can show you Yeah, I'll try to show some other later, right? So if you look at it, right, k contain, so contain. Uh, I'm going to show VL3 router, right? This is a router which is sitting in our cluster, which is manages the inter-cluster traffic, right? Kexec uh, minus this thing minus C VL3 NSE, right? And then minus SH, right? So if you, sorry.
Just missing the IT, kexec-IT.
Oh, sorry, that's the thing. All right, so IP route. If you see, we maintain inter-cluster routes through the inside the pod. So literally, your pod is a vWire all the way to the router, and router puts it into the tunnels across the clusters. So that way you have sharded the traffic, you have a prioritization of the traffic, and you literally have sharded the DNS traffic, right? Any questions so far, or do you want to show something else?
No, I think that wraps up the demo in itself around what we're trying to do or what we wanted to show today.
Yeah. So, there are lots and lots of features which we did not cover in this case. Onboarding is simpler. Bringing the workloads onto the thing is simpler. The networking part is simpler. You don't have to worry about your IP address planning. Literally, your clusters can be templatized. So your overlay network helps you to do connect across multi clusters. The DNS part of it by exporting and importing the thing is important. There are many features which we accelerate from a deployment standpoint, protection standpoint, and as well as availability standpoint. I mean, think about it. You have created a virtual cluster across multiple clusters, right? There is a cluster in GKE, and then there's a cluster in EKS, and then you have combined them, and then now you can literally associate subname spaces inside the slice, and then as well as resource allocation. Your RBAC functionality can be tied to a slice. So and then your all of these things can be coming from your Git repo. And if you put your Argo CD, then everything is now seamlessly available through your pipelines.
So Prasad, given we're a little bit on time, do you mind if I just do a recap of what we did today and
Sure.
let the community know how to reach out to us?
Yeah.
So just to summarize everything that Prasad just said, what you saw today was really us doing multi-cluster connectivity and multi-cloud connectivity. We registered some gateway nodes that allow the slice to communicate between those two clusters, which install the overlay network. The software allows you to do isolation and create security boundaries across your different teams. We're also able to do traffic profiling across the slice. The traffic management is handled by a DNS per slice, so we're able to quickly route the traffic with less latency across those clusters in an encrypted fashion. The installation itself, even though we took a while to just explain what was going on, the installation itself to connect your multiple clusters, in this case it was 3, really takes about 10 minutes or less, just depends on how many you have, but you're able to have a multi-cluster communication just in minutes. So if this is something you want to see in your environment, we're happy to do a POC. Just send us an email at contact@avesha.io, and we're happy to talk about your use case and see if we can help you solve some problems. If you have any direct questions, feel free to reach out to me, rob@avesha.io, or prasad@avesha.io if you have some more questions that you didn't feel comfortable asking here today in the channel.
Yeah.
And again, if you like today's contents, please like and subscribe, and we've got more good content coming out soon. Yeah, in closing, I just want to summarize. So what we've got coming up soon is we're going to release a community edition that will allow you to run this in your own environment. We also are going to do another series around VM cubed, which allows you to bring your VMs into a Kubernetes environment and run those seamlessly with your other workloads running on Kubernetes. So stay tuned for those shortly. And it was great to have you here. So thank you so much for viewing, and we'll talk to you soon.